Give Rowan, a first-time speaker, a big round of applause.
Woo! That guy. He is. You get to keep one of the shot glasses. Probably the one you used.
Have a good time.
Thanks. Hi. So my name's Rowan. I'm an undergrad at the University of Washington. And last summer I was doing research into using ThinSIMs to break mobile money applications. So first, what are mobile money applications? So, sorry. If you've ever used Venmo, then you've probably used a mobile money application. So the basic idea is you have a balance that you can load money into, and it's usually some form of app. Then you can transfer that money to other people and make payments through that way. Now, the ones you've probably seen all run on smartphones, but it's possible to run these things on the SIM card of a phone or over other means. So they're actually very widely used. So there's almost 700 million accounts worldwide, 276 deployments in 90 countries, and transfers over $1 billion a day. Now, a lot of these users don't transfer very much money, though. It's $188 a month, which on average. And that's because they live in places where they don't make much money. So these applications are very widely used in places like Africa and Southeast Asia for people who don't have access to banks. And the reason why they'd be using this over banks is that banks are a lot rarer. And so here you can see there's roughly 500,000 banks in developing countries, whereas there's 2.2 million mobile money agents. So all you need to be a mobile money agent is just have a phone and have access to cash. So the infrastructure required is a lot lower. So it's a lot easier to get access to it. And so if you're a farmer and the nearest bank is a couple of villages away, you probably would not have a bank account with a bank because it's going to take too long to get there. And so the only way you could store your money is by trying to keep it safe somewhere, so maybe burying it at the ground, and that has its own issues, like maybe you lose it, gets stolen. So mobile money is actually a really useful tool for these people to try and be more financially secure. And so it doesn't only run over smartphone apps. The most popular interface is USSD. I'll explain what that is later on. Then there's smartphone apps. Then there's SIM Toolkit apps, which run on the SIM card. I'll explain those as well. And then there's IVR. So this is the interfaces offered by these platforms. So most of them offer USSD. So this is the trade-offs between the different forms of applications. So you've got smartphone apps, which everyone knows what a smartphone app is. It's got a very rich UI. It's very easy to develop for. There's existing development environments. It does not require any cooperation from the phone company. You can just load an app onto your phone, start running it. It needs a data connection, which can be a bit difficult to get in some areas, and also requires a smartphone, of course, which comes with its own host of issues, which means then you have to be able to charge it every day. They're fragile. If you break the screen, that's a big problem. So they're not so useful in these environments, since most people also don't have smartphones because they cost money. So then you've got some Toolkit apps. Now these run on any hardware, so that's good. They also don't require a data connection. They usually use SMS as a backhaul or as a connection back to the servers to make things happen. They've got a menu-based UI, so it's visual. It still requires it requires a lot of cooperation with the phone company, though, because the application needs to be on the SIM card. So you also need a special SIM card that has the application preloaded. And this can be difficult if, for example, you are not the phone company and trying to convince them to put the app on the phone. And then there's USSD, which runs on any phone. Again, it's built into the GSM standards. Does not require any special SIM card. It's got a very standardized UI. It doesn't require data. Still requires carrier cooperation because the phone company has to set up the gateway to allow your application to actually run and give you the number for people to call. However, it only provides a text-only interface. In experience, though, people don't seem to care about this. It's perfectly fine. They don't mind using text-only. It's very fast. They've figured out how to use it in a very fast and efficient manner. So we all know what SIM cards are to some degree, but just to go over it, they identify users on the network. They can authenticate devices on the network. They can do call control, which again I'll explain later, and they can run the SIM Toolkit applications, among other things. So SIM Toolkit applications run on the SIM card. They consist of menus and input prompts. They can also send SMS, place calls, get which cell tower you're talking to, get the phone's IMEI, which is its equipment identifier. and a few other things as well. It's defined by a GSM standard as well. So this is an example of what they look like. So on the left you have a SIM Toolkit app running on a smartphone. As you can see, you've got menus. You tap on a menu and then it might pop up a prompt asking you for text. And then on the right you've got it running on a feature phone or a basic phone. And so then it's still got very similar UI, except you just navigate it with the keypad. So this is an example message flow from a mobile money application. It's a little modified, but the idea still stands. So what you can see is that ME is mobile equipment, so that's the user's phone, and the SIM card is the SIM card. So what you can see is that all messages always start from the phone and then get sent to the SIM card. So here you can see the phone is telling the SIM card that someone entered into an application with this ID. The SIM card then says, great, select an item from this menu. The phone says, here, this is what they selected. The SIM card then asks for the user's PIN. The user provides a PIN. SIM card will then go off and connect to the network and make the payment go through. In this case, it's just hand wavy, but usually this is done through some form of encrypted SMS. And then the SIM card will then display the balance to the user, and the user will terminate the session. So this is what the messages look like. It's a TLV. So you've got the tag, the length of the body, and then the values. So SIM Toolkit commands always start with the D0 and then the length. Then you've got the command details tag. So this will tell you what command you're trying what command is being sent. Then you've got the device identity tag, which I feel is a bit redundant because you can already figure that out from the command details tag, but it basically just tells the phone where the message is coming from and where it's going. And then you've got various tags associated with that type of message. So here you've got a text string tag. This is just saying that this is just displaying text on the screen, basically. So then we've got USSD, or unstructured supplementary services data. So it's dialed like a voice number. No records are stored on the device, however. So while you would dial it with the same phone application that you would usually use to, say, call someone, usually there's a call log associated with that. So you can go back and see which numbers you've dialed before. USSD doesn't have that, so there's no way of going back and checking which USSD numbers someone has dialed. It provides text on the interface, and here you can see it running on a smartphone. This is an application we were using for testing. So this is the format that numbers are in. So it always starts with a star, and the numbers, and a pound, then a pound sign. So the first one would just connect you straight to this service. Now, if you know the service always pops up the same menu when you get there, and you know you want to enter in 1 in the first screen, then you can actually just append *1 to the number, and then that means it'll enter in 1 at the first menu prompt and it'll skip straight to the second one, assuming 1 is a valid input for that. And you can chain this as many layers deep as you want. You'll get stuck though if you make a mistake, and then it will repeatedly try the subsequent numbers on the same screen, which can lead to unexpected behavior. But you can chain it as many layers deep. So in theory, you can do an entire transaction of going through many, many screens just in one command. And this is how most users end up using this service. So now for ThinSIMs, which is what we were actually using in this to do these attacks. So here you can see they're very thin devices. They go between the SIM card and the phone. I have some if people want to have a look at them later, but can't really hand them around. So they fit any size SIM card. So you can see we've got the ones on the left are the ones that we were using for testing. They require cutting out a corner of the SIM card, and as such, they can only be used with mini SIMs. The ones on the right, you see they've got they're much smaller, and so they can work on both nano and micro SIMs as well as mini SIMs. So they're field installable. This means anyone can install it. You don't need specialized equipment. It's kind of like a screen protector in terms of the installation process for some. Then they contain all the functionality of a SIM card. I mean, they're just running code, so you can write anything you want onto it. They're free from carrier restrictions, and therefore they allow third-party applications. This is also useful because the phone company isn't the one putting it in. You can put any ThinSIM you want into your phone, and then they can read and modify all the communication between the SIM card and the phone because they're sitting on the interface. So the original use case for these was cell phone unlocking. So back when you had a GSM phone that was locked to a network, you could put a ThinSIM into it and be able to use the phone on any network, which was very useful. Then the other use case we've seen is distribution of apps. We'll talk about an example of that as well later on. If, for example, you're a company trying to put an application into a SIM card and the phone company doesn't want you to put it on, then you can use a ThinSIM to get around that. And finally, there's the case of malicious installation. So this would be, most of these attacks involve being able to steal money from mobile money applications. So say you're a shopkeeper and you want to make a bit of money on the side, or you run a phone repair business and you're trying to make a bit more money, you could put a ThinSIM in and be able to scrape a bit of money off the top. I'm not recommending this, by the way. So let's look at M-Pesa. So M-Pesa was founded by Safaricom in 2007. The original way it was founded actually was users had these recharge codes that would add balance into their accounts. And they would buy these codes and then send them around as a form of payment. So in exchange of services, you would then send someone, say, a $10 recharge code that they could then either apply to their account for $10 of airtime or sell on to someone else. And eventually someone might sell it back to the storekeeper, to a shopkeeper who would sell it to another user. And so eventually Safaricom realized this was happening and realized that they could make M-Pesa, which was a mobile money application, and cut all this out of the loop and make it a lot more streamlined and safe for the users. So today it transfers 24% of the Kenyan GDP each year, so it's very widely used. It's expanded to many other countries, and it definitely runs over a SIM Toolkit application. It's not necessarily currently the primary way it runs, but it's definitely run over that in the past. And so then Equity Bank came along in 2015. So they wanted to run their own mobile money application. And so because they came along, and because they wanted more people to be able to use it, they couldn't run it on a smartphone app. So they needed to use either USSD or a SIM Toolkit. And for whatever reason, they decided to run it as a SIM Toolkit application. Now, unfortunately, Safaricom had 80 or 90% of the market share. And of course, they didn't want to put a competing application onto their SIM cards. So as a result, that forced Equity Bank to try and distribute their app as a ThinSIM. So there was a court case about this with Safaricom trying to stop them from doing this. The court eventually allowed them to do it, but there was very little. No one really looked into the security implications of this. So here you can see a phone with a ThinSIM installed and an app running on the ThinSIM. So you notice that all the traffic goes from the phone to the ThinSIM. It never touches the SIM card. This is all fine. No data is really at risk here. Then when you've got an application running a SIM card, however, this diagram makes it look like the data is traveling from the phone to the SIM card. But really what's happening is it's being sent from the phone to the ThinSIM. The ThinSIM is then deciding to forward it onto the phone. And then onto the SIM card, and then the SIM card can process the data and send it back. But the ThinSIM is processing all the data as it goes through. So there's probably some fun things to be done here. So what if the ThinSIM is not friendly? What if there's some malicious code on it? So there's a lot of things that the ThinSIM can do. Let's just look at the first three for the first attack. So this is the ability to intercept, modify, and create SIM Toolkit commands, then view the response to those commands in plain text, and then the ability to send SMS messages without notifying the user. So this attack was primarily targeted at the M-Pesa SIM Toolkit application because we needed a target platform. We also did some testing against Airtel, and with some modifications, just because it's got a different menu structure, it would work against that as well, and probably any other SIM Toolkit-based mobile money platform. So the attack takes place in two phases. You've got first we steal the credentials, and then we actually make the fraudulent payments. So here you've got a phone, ThinSIM, and a SIM card. So initially there's a transparent, the user is using the SIM Toolkit app, and it's not clear at all there's a ThinSIM installed. They can't tell. They're just using the SIM Toolkit app on the SIM card. Everything's normal. Eventually the app will ask the user for a PIN, and at this point the ThinSIM will start listening. Then the user will respond with the PIN, and the ThinSIM stores the response. At this point, the ThinSIM has stored their credentials for later use, and the user doesn't know anything about it. So then we have a demo. Okay, so this is me entering into the M-Pesa app. So first I check to see there's no. So let me just start this again. Okay. So what I'm going to do is first check that verify there's no PIN stored, then enter into the M-Pesa app, try and check my balance, and then view the PIN afterwards to show that it's captured. Now, unfortunately, Safaricom SIMs, if you don't use them for too long, they become they're no longer active, and so this one we didn't use for too long, and as a result, it can't actually send SMS messages. But the attack, this still proves the first half of the attack. So here I go and view the PIN that is stored. It says no PIN is captured. So then I go into the M-Pesa app, navigate through some menus, check the balance. It then asks for the PIN. It says OK. And then it fails to send the SMS because it's not active on the network. Exit out, view the PIN, and now we have the PIN stored. So back to slides. That one? No. That one. Okay. So now for phase 2. This is where we actually go and make the fraudulent payment. So again, you've got the phone, ThinSIM, and the SIM card. So first there's a status update. Now these status updates are sent roughly every 30 seconds from the phone to the SIM card. We're just using this as a way to trigger the attack, although it could be triggered through various other means. So once the ThinSIM decides it wants to start the attack, it then begins a transaction, it begins a SIM toolkit session with the SIM card. In this session it goes and sends all the data required to initiate a transaction. The data sent is exactly the same data that the SIM card would expect to see if a user was interacting with the SIM card. Eventually the SIM card will then try and contact the network. This is via sending an SMS. Now, usually this would pop up a notification on the screen. However, that would tell the user something bad has happened, something weird is happening, and they might be able to try and stop whatever is going on. So let's see if there's a way around that. So here you can see this was one frame taken out of the previous video. Unfortunately, if the SIM card was active, it would have been more obvious what was going on. But here you can see that there is a message at the bottom telling the user that the application is sending an SMS. Now, the application can specify the string. So here we've got the message that was actually sent. The SIM card sent to the phone to make this SMS happen. So you've got all the stuff at the start with the command details and the device identities. And then you've got this text string. And this is what is actually displayed to the user. And then that's followed by the SMS TPDU, which is the body of the SMS and where it's going and all those boring things. So how can we make this go away? Now you might think, oh, let's just remove the text string and maybe it will disappear. Well, unfortunately that leaves it up to the phone to decide whether it wants to display something to the user. And most phones will display something to the user telling them that an SMS is being sent. But however, if you just give it a null string, so just tell it you've got a string of 0 length, nothing shows up. And so then you can send an SMS without the user seeing anything. So that's what we do. So if we go back, the SIM card is trying to send an SMS. The ThinSIM takes the message, removes the bytes that would make something show up on the screen and replace it with a 0 length string, and then sends a silent SMS that doesn't show up to the user. So what this looks like No. Okay. So let's start again. All right. So what this looks like to the user. So we can just verify we've got the PIN stored. And then we start the attack. Then the user won't see anything. Unfortunately, because the SIM card is not active, it will still show the failed send SMS, but the other message didn't pop up ahead of time. It's there in the logs, and the ability to send silent messages is shown in another demo as well. So that's the oh no, okay. So at this point, we've successfully done the transaction. There's no indication to the user that the money has gone anywhere or anything's happened really at all. Okay, cool. So let's go back to the list of capabilities that we have. So we've already used the first three. So let's look at the next two. So the ability to log and redirect calls, both for voice and USSD, and the ability to make USSD calls without notifying the user. So this is done via call control. So what call control is whenever you dial a number to call on your phone, first the phone will actually ask the SIM card. So say you then the phone asks the SIM card, hey, can I call this number? And the SIM card will respond, yeah, sure, here you go, you can call the number. However, the SIM card can also say, no, you can't call that number, and just deny it outright. Or it can modify the call and say, sure, you can call a number, but replace it with this one instead. Now, interestingly, for voice calls, depending on the phone, this may or may not show up in the call log as being redirected. On the Android phone we had, it did show up as being redirected. However, on the feature phone we were testing on from 2005, was running some Windows operating system, it didn't show up, and it showed the original phone number. So this doesn't sound too bad, right? It's just messing with what people are calling. But there's lots of fun things to be done with this. So because USSD is not usually tracked, maybe you're using a USSD service that you wouldn't want other people to know you're using for whatever reason. So if you had a ThinSIM installed that was looking at call control, it would then be able to see who you're calling, which can then be used for advertising, surveillance, blackmail, whatever you want. It could also be used for phishing attacks. If you're ever trying to set up a fake customer support line and trying to get someone to call it, this makes it a lot easier. You just make them call the original customer support number, it redirects to your own number, and then you can get away with whatever social engineering attacks you're trying to do. You could also route all their calls through some premium number and just make their phone bill go really high and charge them a lot of money that way. Of course, it would be a premium number you own, so you get the money for it. Or you could redirect USSD calls. Let's see what happens if we do that. So for the USSD attack, it takes place in two phases. Again, you've got stealing credentials and making transactions. However, this requires attackers to set up their own USSD service, which the other one didn't require the attackers to set anything up. And depending on the country, setting up a USSD service can be anywhere from easy to almost impossible. For example, in the US, no one really uses USSD. I've never seen any USSD sessions. The closest I've seen is, for example, with AT&T, you dial star, data, pound, and then it will send you an SMS back with the data usage you've got for that month. So this is the setup we had. So we've got a laptop running the Osmocom network in a box, which is some cell software, a cell tower software. Unfortunately, no out-of-the-box cell phone software I could find that was open source had functioning USSD capabilities, so we had to modify it a bit with various patches from various years, and it worked in the end. Then we've got USRB B210, which is actually the radio we're using. Then you can see we've got a phone sitting there with a development module ThinSIM plugged into the back of it, and then a debugger attached, so I can view the messages that are actually being sent between the phone and the SIM card for debugging purposes. So here you've got a phone, the two services. So you've got the legitimate one that the user is trying to access, the attacker's service that they've set up, and then you've got the ThinSIM and the SIM card as before. So the first thing the user is going to try and do is they're going to try and dial the number for the legitimate service. Now this initiates call control. So it then asks tries to ask the SIM card, can it dial this number? However, because there's a ThinSIM installed, the ThinSIM intercepts that and decides to redirect it somewhere else. So it then gets redirected to the attacker's service. Now the attacker's service will mimic all the menus for the legitimate service perfectly. And so the user will go through all the menus they're expecting to go through and enter in all the payment details. However, right before the very end that would actually right before the very end of the transaction that would actually send the money, the attacker's service will return an error. This is because it can't actually make the transaction go through. The user will likely interpret this as some kind of network connectivity issue and try again later, at which point it would go through with no issues. So we have a demo of that as well. Okay. So in this demo, I'm going to dial the number for our USSD service, and then it will redirect it to the attacker's service. So now I'm dialing for the legitimate service. It gets redirected without telling the user anything. So we go through and then enter in to check the balance. So we type 1, press OK. So then it asks the PIN. error occurred, try again later. So we exit out of this. Okay, just mute that. So we try again. I don't know why it takes so long to access the USSD service. It really shouldn't, but it does. So then we go through and we try and check the balance again. So we enter in 1 to check balance. Again, we go and enter in the PIN. And now we actually get the balance. So notice this is 9,001, so over 9,000. All right, so let's go back into this. Okay, so that's the demo of phase 1. So then in phase 2, we actually go and try and steal the money. So again, this is triggered through some means. In this case, we just triggered it through a menu item in the SIM Toolkit application. However, again, it could be triggered through a status update or something of the like. So first, the ThinSIM will call the attacker service because it needs to get the PIN back. So it will call the attacker service and retrieve the PIN. Next, so then it gets the PIN back, and then it will actually make the transaction. So when it does here, it strings together the entire command it would need to do. So it'd be like *123, *2 for make transaction, and then the destination phone number, another *, then the amount they're trying to send, *1 for confirm, and then the PIN, and then £. That's the string we need for this service in particular. So we have a demo of that. Okay. So going to the SIM Toolkit application. So we select send USSD. It waits for a while because it doesn't display to the user anything is happening. Usually it would, but we've made it silent. So now let's go and check the balance to see that we've actually sent some money somewhere. So now we go through and actually go and check the balance. Enter in the PIN again. And now the balance is much lower. This is sending a bit over 600 current units of currency somewhere to another account. So at that point, there's not really a lot the user could do. The money's disappeared. By the time they notice, it's probably been shifted to another account or cached out of the network so that there's no method for recourse. And customer service in these places is often not so great, so there's very little chance of users getting their money back. So there are a couple more capabilities I didn't really talk about. There's the ability to track location updates. So this is what cell tower the user is talking to. You could make some snooping software to track users doing that. There's GSM authentication. This is not really so much an attack, but you can use it if you know the IMSI of the device of another user and the key for the network. You can then pretend to be that user. And then you can read any data off the SIM card, including the IMSI and the phone book if that's stored there. Also in the GSM standards, it allows phones to store SMS messages on the SIM card. And in the case where that messages are being stored on the SIM card, the ThinSIM would be able to read those as well as they went past. So let's look at some possible defenses now. So you could disable call control. This would get rid of all the call control based attacks as well as the USSD based attack because if you can't redirect the call, the attack is completely impossible. However, that requires modifying the phone standards and then updating all the phones, which is not really going to happen because a lot of the users who would be affected by this don't have data, and if they have data, they want to use it for Facebook and WhatsApp. That's what they're going to use it for. And so they're not going to install apps. They're not going to install updates. It's probably not necessarily possible to install software updates over the air for these devices as well. Not all the companies that made the devices are even still around necessarily. So then there's the ability to disabling silent outgoing SMS and USSD. Well, this wouldn't actually prevent the attacks. All it would do is prevent the notification, make it clear to the user that something bad is happening. Now again, unfortunately, this requires modifying the standard and has all the associated difficulties. You could discourage the use by encouraging phone companies to put third-party apps onto their SIM cards. This would then require a lot of cooperation from phone companies who may not want to cooperate and may have financial incentives not to cooperate. In the case of Safaricom, this would at least make ThinSIMs not normalized. So if someone saw a ThinSIM, at least then they'd be very suspicious of what's going on. You could use confirmation codes. So for SIM toolkit and USSD, you could send the confirmation code after the transaction has gone through. Then the user would have to enter in that confirmation code in order to verify the transaction and make it go through. This works great for phones where the SMS messages are not stored on the SIM card. But if it's stored on the SIM card, then ThinSIM has access to it, and so this is completely useless for those devices. I don't know how many devices out there have that functionality, so I don't know. And then for USSD, you could require the user to enter in confirmation value on the screen. So this doesn't work with SIM toolkit because it would need to talk to the network. But the essential idea is that once you start the USSD session, there's no indication the SIM card can't interact with it anymore. So if the session completes and gets to the end without having to require any more input, the SIM card then does get the response, the final response that is sent back. But if it needs more input, it will then ask the user for it, and there's a prompt that shows up. So what this would mean is that the ThinSIM would not be able to completely predict the message that it would need to send, and something would show up on the user's screen that would allow them to then deny the payment, deny the transaction, and stop anything bad from happening. So this would be quite effective. And finally, it's a plain text interface. Why can't we just encrypt it? And well, there is actually a standard for that. However, of course, no one implements this standard. That would be too sensible. Yeah, it's been around for many years, but there's no implementation of it. So there's a link to the paper that I use that was written for this, presented at a conference in June, and then these are a couple of standards that there are. Does anyone have any questions? Yep. So what was that? If you buy your own SIM card, I mean, you'd. So, as in for seeing those as the SIM installed? Yeah. So the thing, if you look at your SIM card, it would be very clear if there's a ThinSIM installed or not. It's very obvious. Yeah. However, the interesting note, it might be possible to do all these attacks if you actually had software running on the SIM card itself. So, if you had supply chain issues, for example, you might also not be safe. Yep. I don't believe it's possible to get the key off the SIM card. If it was possible, ThinSIM might be able to do it. Yeah, it's not really something we looked into. What else? Cool. Thank you.